Hi, this question, which is based on vectors, alright, it's a very interesting question which is coming from paper 1, and F is a point on AB such that AF is equal to 1/4 AB, alright, and also E is the midpoint of AC. E is the midpoint of AC. Given that AF is equal to 1/4 AB, AF 1/4 AB, and AE is equal to vector P, so A to E is vector P, and A to F is vector Q. Now, if AF is equal to 1/4 AB, what it means that AF divided by AB should be equal to 1/4. So this is 1 and this is 4. Basically, that 1 and AB is 4. So AB is 4, 4 minus the 1, so that's going to be 3. Alright, because the total is 4. 1 plus 3 is 4. Very good. First thing, we need to express FE in terms of vector P and vector Q. So part A of the question, first part, we need to find the vector FE. Now here is, I've already drawn a line for you. FE is FA plus AE is FA plus AE. So FA is going into the negative direction, that's going to be minus Q plus AE, and AE is vector P, meaning that this is P minus Q, and we are done for the first part of A. So this is your vector FE. Now we need to find also the vector BC, alright, in terms of vector P and vector Q. Okay, so how are we going to find BC? Alright, so let's move on and see. This is B to C. BC is BA plus AC. So we have BC is equal to BA plus AC. Now we know that BA is equal to how much? If this is Q and this is, the ratio is 1:3, it means that this is going to be equal to 3Q. Right? So we got then 4Q, but remember you're going in the negative direction. You want to find BC, so you go BA plus AC. You know AB. AB is 4Q. So BA is minus 4Q. So that's going to be minus 4Q. Alright, minus 4Q plus vector AC, and AC is what? 2P. So P and then P. Remember, E is the midpoint. If E is the midpoint, then this is going to equal to P. Right? So we have got 2P then. So plus 2P. I mean 2 vector P minus 4Q. Here we are for the second part of A. Now, for the part B, D is the point on BC produced such that BD is equal to KBC. Okay, here we go. Okay, we want to go from B to D. We're going to have to multiply BC by K. So what are we saying is that for this part here, for part B, first part, express FD in terms of K. Okay, so we want to find FD, alright, and this is going into this direction. Okay, so let's say D is a point here, right? So we want to find FD. This is like a straight line, eh? So FD is equal to FB plus BD. FD is equal to FB plus BD. And what is FB? FB is 3Q, alright? So we got then 3Q plus BD. And BD is here. Look. It's K times BC. So plus K times vector BC. So that's 3Q plus K times BC, and BC is 2P minus 4Q. Right, now from here we're going to have to distribute this. So 3q plus 2k vector p minus 4k vector q. The q and the q can be on one side, so I've got 2k vector p, 3q minus 4kq plus 3q minus 4k times q. And as we see that q and q is common, and I've got 3 minus 4k inside, and the q can stay outside. So this is FD in terms of vector p, vector q and k, where k is a constant. Now, this is the first part of B. Given, for the last part, that f, d and e are collinear, find k. This is a bit like parallel vectors. Collinear points. What do we know about collinear points? Collinear means the points lie on a straight line. So, for instance, as you can see, the examiners made it a lot easier for me to explain it to you. Why? Because it's already said that what's the condition for collinear points? That if you are moving from one point to the other point, from here to here, you have to multiply by some constant to get the whole line. Okay, so BC here times K is equal to BD, and that's been given here. So they want us to find the value of K. Alright, so how are we going to do this? Okay, we know FD, alright, and if we know FD, okay, we can then find the value of K. Now, as I said, we know FD. We can also find FD, alright, here, because F to D is FE multiplied by some constant and some scalar. It's going to give you FD. So FE multiplied by, let's say, H is equal to FD. We found that FE was P minus Q. So FE is vector P minus vector q times h is equal to fd. Therefore, fd is going to equal to ph, vector ph minus vector qh. You can see that this is fd and then this is fd, these two. Alright, so what we can do, we can equate the coefficient of vector p and vector q. Let's do this here. The coefficient of vector p is h. So I've got h is equal to coefficient of vector p is 2k, and this is 2k. That's my first equation. Then for the second one, I've got minus h is the vector coefficient of vector q. This is minus h. Let's bring this down here. Just get the middle one. So this one may be much better. I've got minus h is equal to, and vector q, the coefficient of that one is 3 minus 4k. So it's equal to 3 minus 4k. This is my second equation. Now this equation here can be turned into h is equal to, because this minus can go on the other side, it becomes 4k minus 3. The h can be substituted in the first equation. The first equation is h is equal to 2k. So we got h, which is this, 4k minus 3, that's h. h is equal to 2k, it's equal to 2 times k. So 4k minus 2k is equal to 3. And therefore 2k is equal to 3, and then k is equal to 3 over 2. And that's your answer. It does make sense because 3 over 2 is 1.5. And if you only take a value of k which is greater than 1, alright, and you multiply by this, bc times some number which is greater than 1 is going to extend that line to d. And that's why they say the line is produced. It can only be produced if the value of k is greater than 1. And we got 3 over 2, which is greater than 1, makes it off sense to me. Alright, take care.